Chapter 1, Lesson 1.7, Represent Functions as Graphs. In this first example, we're asked to graph the function y equals 1/2 x with the domain of 0, 2, 4, 6, and 8. The first step in graphing this is to make an input-output table. So you're going to plug in the values of your domain into your x values, and then plug those values into the function to find the y values. So when I plug in 0, 1/2 times 0 is 0. When I plug in 2, I get 1/2 times 2 is 1. Plugging in 4, half of 4 is 2. When I plug in 6, half of 6 is 3. And plugging in 8, half of 8 is 4. The next step is to plot a point for each ordered pair x comma y. So here we have plotted the 5 points. The x values are on the x-axis, which is the horizontal axis, and the y-axis is the vertical axis. So you're going to travel 0, 0 as the first point, and then the point 2, 1, you would travel from the origin 0, 0, 2 units to the right and 1 unit up and make a point. For the point, for the ordered pair 4, 2, you would travel 4 units to the right and then 2 units up and make another point. For the ordered pair 6, 3, you would travel 6 units to the right and then up 3 units. And the ordered pair 8, 4, you would travel 8 units to the right and then up 4 units. So let's do another guided practice that follows example 1. Graph the function y equals 2x minus 1 with domain 1, 2, 3, 4, and 5. So you can make a table first. Let's do that. So when I plug in 1 into the function, 2 times 1 is 2, 2 minus 1 is 1. When I plug in 2 as x, you would multiply 2 times 2 is 4, minus 1 is 3. Plugging in 3, I have 2 times 3 is 6, minus 1 is 5. Plugging in 4, 4 times 2 is 8, minus 1 is 7. 5 times 2 is 10, minus 1 is 9. So these are my ordered pairs. And then when I plot them, for the first point 1, 1, you would travel 1 unit to the right and up 1. For 2, 3, you travel 2 units to the right and then up 3. 3, 5 is 3 units to the right and up 5 units. 4, 7 is 4 units to the right and up 7. And 5, 9 is 5 units to the right and up 9. Example 2. So here's a word problem about SAT scores. The table shows the average score S on the mathematics section of the Scholastic Aptitude Test, SAT, in the United States from 1997 to 2003 as a function of time t in years since 1997. In the table, 0 corresponds to the year 1997, 1 corresponds to the year 1998, and so on. Graph the function. So here's our table, and here's our data. The first step is to choose a scale. The scale would allow you to plot all the points on a graph that is in a reasonable size. The t values range from 0 to 6, so label the t-axis from 0 to 6 in increments of 1. The s values range from 511 to 519, so label the s-axis from 510 to 520 in increments of 2. The second step is to plot the points. So when we do this, this is what our data looks like. This little squiggy here means you skipped a bunch of numbers and you started here at 510. And so that allows us to fit all of the data into one reasonably sized coordinate plane. Here's a guided practice to follow example 2. What if? In example 2, suppose that you use a scale on the s-axis from 0 to 520 in increments of 1 unit. Describe the appearance of the graph. Well, what happens is, because most of the data is above 510 and maxes out at 520, all of you'll have a big gap at the bottom where there's no data points at all. So all the data points would be at the top of the graph with a lot of blank space below it. Example 3. Write a rule for the function represented by the graph. Identify the domain and the range of the function. So the first step you want to do is to make a table for the graph. So we would list each point. So this first point here has an x value at 1 and a y value at 2. So my first ordered pair is 1, 2. The second point here has an x value of 2 and a y value of 3. So here I have 2, 3. The next point has an x value of 3 and a y value of 4. This one has an x value of 4 and a y value of 5. And the last point has a value of 5 on the x and a value of 6 on the y. Once you have your table, you want to find the relationship between the inputs and the outputs. Notice from the table that each output value is one more than the corresponding input value. So, to write the function of the rule that describes a relationship, that means that for every x value, the y value is 1 more than. So the equation would be y equals x plus 1. A rule for this function is y equals x plus 1. The domain of the functions is 1, 2, 3, 4, and 5, which are the x values. The range is the y values, which is 2, 3, 4, 5, and 6. Let's do a guided practice following example 3. Write a rule for the function represented by the graph. Identify the domain and the range of the graph. So here, we will make a table. I'll make a vertical table. So my first point here has an x value of 0 and a y value of 5. My second point has an x value of 1 and a y value of 4. My third point has an x value of 2 and a y value of 3. My fourth point has an x value of 3 and a y value of 2. My last point has an x value of 4 and a y value of 1. So the second step is to look at the relationship between the input, which is the x values, and the output, the y values. So as you notice, the y values when x is 0, we have 5. So that's our original y-intercept, right? So we're starting with the output of y. So y starts at 5 when x is 0. And as we increase our x, our y is decreasing. So if you look here, the difference is subtracting 1 every time. So that describes the slope of the line. It's decreasing by 1. So essentially, that's the coefficient of the x. So negative 1x. So 5 minus x gives you your y value. So let's test this out. So if I say 5 minus x, I get 5. 5 minus 1 gives me 4. 5 minus 2 gives me 3. 5 minus 3 gives me 2. And 5 minus 4 gives me 1. So that works. So my solution is y equals 5 minus x. That's my answer for the function. My domain will be all the x values, 0, 1, 2, 3, and 4. And my range is all the y values, which is 5, 4, 3, 2, 1. Here's another one. Write a rule for the function that's represented by the graph. Identify the domain and range. So here, my table will say, my first point is 1, 10. Second point is 2, 15. Third point is 3, 20. And then I have 4, 25. Okay. So if I were to extend this line here, I would see that there would be another point right here. So I'm really starting this at 5. Okay, and my slope is, I'm rising 5, running 1, so slope of 5. So it's 5. I started at 5, that's where it crosses the y-axis. It's an increasing function, increasing by 5 every time on the y, so 5x. Okay, so really in standard form we should write it 5x plus 5 is my rule. And my domain is 1, 2, 3, and 4. And my range is 10, 15, 20, and 25. Okay. The graph shows guitar sales in millions of dollars for a chain of music stores for the period of 1999 to 2005. Identify the independent variable and the dependent variable. Describe how sales change over the period and how you would expect sales in 2006 to compare to sales in 2005. So here is the graph. So the independent value is the number of years since 1999. The dependent value is the number of sales in dollars. The graph shows that the sales were increasing. If the trend continued, sales would be greater than 2006 than it would be in 2005. Based on the graph in this example, 4 is 1.4 million a reasonable prediction for the chain of sales for 2006. Explain. So if you look at this graph, yes, the graph seems to increase about $0.2 million every 2 years. This concludes our lesson.